Hello students, welcome to today's session. So last time we were discussing variable declaration and today we'll continue our discussion. So we have already seen how we can declare variables. Now I want to talk about declaring multiple variables in a single statement. Okay, multiple declarations in a single statement. So let's say I want to create three variables of the same data type. So I can do it in a single statement like this. Let's say I want to create character type of variable. Okay, so char C1 comma, separate the variables by comma, C2 and C3. Okay, so what have I done here? I've created three variables C1, C2 and C3. Their data type is same character. Okay, this particular comma is separating C1 from C2 and this comma is separating C2 from C3. So recall, comma is used as separators, right? From the previous chapter, not the previous chapter, from the previous video, when we were discussing separators, we looked at comma is used as separators. So here you can see the practical example how it is being used as separators. It is separating identifiers. So this is how you can declare multiple variables in a single line. So for example, here the three variables have been declared: day, month and year. Okay, their data type is short. So day is also of short type, month is also of short type and year is also of short type. Okay, another example, two variables have been declared in a single statement. Both of them are of type float. So gross pay and net pay, both of them are of type float and they have been declared in a single statement. And notice that you have to use comma here. Okay, but at the end of the statement it's a semicolon, because semicolon is used for terminating the statement. This semicolon will terminate the whole statement. So you should be clear regarding where you have to use comma and where you have to use semicolon. So this is about multiple declarations, multiple variable declaration. Next, let us talk about initialization. So variable initialization, what does it mean? See, when you assign a value into a variable for the very first time, that is known as initialization. For example, in this statement, I have declared three variables. That means I have created three containers. They are capable of holding character kind of data. Their label is C1, C2 and C3. But they are not storing any content. They are not storing any kind of data inside them. Okay, so when you store a value inside them for the first time, that is known as initialization. So how is it done? Initialization is done with the help of assignment operator. So the equal to symbol, which you normally call as equal to, in Java it is known as the assignment operator. This assignment operator will initialize the variable. And not only initialize, whenever you want to change the value of the variable, you have to use this assignment operator. For example, let's say if I write C1 is equal to let's say hash. Okay, hash is within single quotes. Why? Because C1 can only store character literals, because C1's type is character. That is why character literals can be assigned to C1. Okay, and let's say in C2 I have initialized it with percentage symbol, and in C3 I have assigned the character, the alphabet W. Okay, so this is known as initialization of C1, this is initialization of C2, and this is initialization of C3. So when this line is executed, what will happen? The container C1 will store the value hash. When this line is executed, containers or variable C2 will store the character percentage. Okay, so this is known as initialization. Now in this example I have done the declaration and initialization separately, but we can do it in a single statement. Okay, instead of doing it separately, I can do it in a single statement like this: C1 is equal to, let's say, hash. Okay, so in a single statement I have declared C1 as well as I've initialized it with hash. Similarly, I can have multiple declarations and initializations. So I have to put a comma here and I will declare my second variable C2, okay, and I can initialize it here only. So now what has happened? Two variables C1 and C2 have been declared and initialized simultaneously. Okay, so this is how you will initialize variables. And one more thing is that when you are trying to initialize a variable, it does not have to be a literal. Okay, what do I mean by this? Let's say I've declared an int type of variable num1 is equal to 10. Okay, now if I want to create another variable, then it's not necessary that I have to use an integer literal here. Okay, I can use another variable's value to initialize this num2. So instead I can write here num1. Okay, so what's happening here? See, num1 is storing 10, right? Num1 is storing the value 10, the data 10. Now when I create another variable num2, so inside the computer's memory num2 will be created, okay, and the value of num1 will be copied into num2. So what is num1 storing? Num1 is storing 10, that means num2 will also get the value of 10. So both num1 and num2 will store the value 10, and we can confirm it by printing out the values of both the variables. So as you can see, num1 is also 10 and num2 is also 10. So initialization can be done with the help of literals or using another variable. Now let's talk about default data types. Okay. See, when you declare a variable and you don't assign any values into those variables, they will get default values. Okay, the compiler will assign them default values. Okay, so byte is assigned with the value 0, short is initialized with 0, int is also initialized with 0, long is also initialized with 0, float is initialized with 0.0, and f. So a float number is always ended with f, the letter f, either small case or capital case. Similarly, double is also initialized with 0.0 and you end it with d, small d or capital D. Okay, so default value of float is 0.0f, default value of double is 0.0d. Okay, and in case you write a decimal value, let's say 2.5, without writing f or d, by default it will be taken as 2.5d. By default it will become a double value. Boolean is initialized with false by default, and character is initialized with null by default. And non-primitive types are initialized with null. So let's check this. So as you can see, I've declared 9 different variables with different data types, and at the present moment I'm getting an error here. What is the error? The error is variable b1 is already defined in class data types. That is, I've already declared a variable with the name b1. That means I cannot declare another variable with the same name in the same class. Okay, if it was a different class, I could have used the same name, but inside the same class I cannot have the same name for 2 different variables. This is not allowed. So I will change the name of this variable I can change the name of either byte type or the boolean one. Okay, any one you can change. So I've changed this one. I've renamed it to B. Now let's print the values of these variables. See, at the present moment I've just declared these values, right? I haven't used the assignment operator to initialize those variables, but the compiler will by default initialize them with the default values. So I'll print all the values here. C1, B1, this is S1, I1, L1, this is F1, this is D1, this is B, and this is S. So first C1 got printed. C1 was initialized with null by default. Okay, so that is the meaning of this null. C1 was character type, right? So character means it will be initialized with null. So this is how null looks like. Null means nothing. Okay, so C1 is null, B1 is 0, S1 is short 0, I1 is int 0, L1 is of long type, it is 0, F1 is of float type, it is 0.0 F. Okay, although F is not written here, but it's F. Okay, then this one is 0.0 D double, D1 is double, B1 B is boolean type, so it has been initialized with false, and S is of type, it's actually non-primitive. Okay, see, here is an interesting point. All these variables here, they are what? They are of primitive type. Okay, whereas this particular type, string type, is non-primitive. It is non-primitive. Okay, so this is what is meant by this statement. Default value of non-primitive type is null, null. So that's why for S you can see it's null. Okay, default value of S is null, null. So that's it about default values. So this particular program, I hope by now you can understand, and this program is good for understanding the whole summary of this chapter. So what is this? This is a literal, all these values here to the right side of the assignment operator, to the right side of the assignment operator. Okay, so this one, this one, this one, this one, this one, all these values are literals of different types. So this one is byte, this one is short, this one is int, this one is boolean, this one is string. Okay, this one is character. So all the different literals are present here. All the different literals are present here. Whenever you have a boolean data type here, that means you can assign only a boolean value. Whenever you have a string data type here, you can only assign a string value. Whenever you have a character data type here, you can only use a character literal here. So these points must be understood. So this one is a literal. What is this? This one is variable and this one is data type. Okay. So data type, variable and literal, isn't it? This whole chapter is only about data type, variables and literals. So all the concepts have been used here in this program, and this program is a very simple program. I hope you can understand what's going on because I've already explained each and everything. Now some of you may get confused here. Okay, so let me explain this part. Let's say I've created a variable with the name num1 and I've initialized it with 10. So what do you think the output of this program will be? Will it be 10 plus 10? Will it be 20? Or what? The output will be actually num1 is equal to 10. Okay, there is a space here and a space here because there is a space here and here. Let's see the output first. So as you can see, the output is num1 space equals to space and then 10. How is this happening? Why is this num1 being printed as num1 whereas this num1 is being printed as 10? Why is this happening? See, this point is very important. Whenever you have something present inside double quotes, okay, that whatever the content is inside, it will get printed as it is. Okay, whatever the content is present inside double quotes, it will get printed as it is. So from the character n up till this character space, okay, this space, it will get printed as it is. Okay, and then finally this num1 is without double quotes. There is no double quotes here. Okay, there is no double quotes. That means the compiler will understand that we are talking about the variable num1. We are talking about the variable num1. So it will go into the computer's memory. It will see it will locate where is num1. When it locates num1, it will find out that there is 10 stored there. So it will bring that 10 here and it will replace this num1 with 10, and then finally it will get printed on the screen as 10. So this is how it works. So this is the reason why byte var colon space gets printed here as it is, and that this byte var is actually the name of the variable. So the compiler will go get the value from the RAM of byte var and it will print it here. So this is very important point. Please remember it. Next, let's talk about constants. Okay. So at the present moment, the value of num1 is what? 10. So 10 is getting printed here. What if I change the value of num1 here as 20? Okay. So what do you think the output will be now? So this line num1 is equal to 10, but this line is printing num1 is equal to 20. Okay. So the value of the variable can change at any time. The value of the variable can change at any time. When the control was here, the value of num1 was 10. Okay, that is why num1 in the RAM, num1 is storing 10 because of this particular statement. So when the control comes to this particular line, the value of num1 will be printed as 10. But when the control comes to this particular line, num1 will be replaced by 20. Num1 will be replaced by 20. Hence, when we try to print the value of num1 here, num1 is printed as 20. So the value of a variable can change at any time during the program execution. But there are certain situations when we do not want that the value of the variable should change. In that case, I can declare the variable as final. Okay, when I declare the variable as final, that means whatever value is initialized, the first time the value is initialized, that value will become the final value. You cannot change the value. And look what happens. Look here, num1 is giving me an error, cannot assign a value to final variable num1. Earlier it was working when the final keyword was not present here. This line was not causing any error. But as soon as I've put a final keyword here before this declaration, num1 cannot change its value. It will always remain 10. That is why this is giving me an error. This is not possible. Okay, so if I remove this line now, so now you can see num1 is 10 and num1 is 10. Okay. So why do we need final value variables, constants? Okay. Because it improves the readability of the program. It makes it easier for someone to understand the code. Okay. Second advantage is that it prevents you from making any unintentional changes. Okay. Let's take this example. See, the value of pi, I've declared a variable as pi and I've made it final. So the value of pi will always be 3.14. It cannot be anything else. The value is a fixed constant, isn't it? 22 by 7. So 3.14. So this will come to 3.14. So this is a universal constant the value cannot change. If you change this value, it will result in erroneous calculations. Okay, it will result in calculation with errors. So ideally you will never want to change the value of this variable pi here, but by mistake if you write somewhere pi is equal to 5, okay, so by mistake, so pi will become 5 here, and the whole formula, the whole calculation will give you the wrong value. So to avoid these kind of situations, you can declare the variable as constant using the final keyword, so that even by mistake you will not change the value of this particular constant. And one more advantage is that if you want to change the value, okay, so for example the rate of interest, see, you know that the bank gives interest, isn't it? If you keep some money in the bank, it will give you some interest, isn't it? And that interest rate differs every year, okay? It might differ every year, it might be different. So let's say in 2020 the rate is 0.08, that is 8%. So the wherever you use this variable interest rate, this constant interest rate, okay, throughout the program the value of this interest rate will be 8%. But let's say 2021 came and you want to revise your rate of interest, so you can easily change the value at one place, okay, and wherever interest, let's say you want to change the rate of interest in 2021, you have to change it just at one place, okay, and it will reflect in the entire program. So this is the final advantage of using constants. Finally, let us talk about comments. So what do you think the output of this program will be? I've compiled it and there is no syntax error. So what do you think the output will be? Will it be hello? Let's check it. There is no output. See, some of you might think that this is a statement, executable statement. But no, it's not an executable statement. Why? Because I've put a double forward slash. I've put a double forward slash. So what will happen is that the compiler will ignore whatever is coming after this particular symbol, okay? So double forward slash, whatever is coming in this line here, the compiler will ignore it. So this is known as comment, okay? So comment are generally used for writing comments, your own comments about the program, about a particular statement, okay, about what a particular statement is doing. For example, if I declare int num1, okay, so I can write a comment here, it will store the first number. Then I can write int num2, semicolon, double forward slash, it will store the second number. Okay. So by writing the comments, you can explain what each and every statement is doing, what the whole program is doing, so that when you refer to your program few months later, okay, because a program will contain thousands and thousands and thousands of lines of code, okay. So once you have written the code and you come back to your code after many months, you might not know what you have written. You might not be able to understand your own code. That is why you should comment your code so that you know what's happening in each statement. So that is why comment is used. So far we have seen this single line comment. Double forward slash is used for single line comment. Okay. The effect of this double forward slash is in just a single line. But if I bring my cursor to the next line, if I start writing here, you can see that this line will be executed. Okay. So if I want to write multiple line comments, if I want to write my comments in multiple lines, I can use this forward slash asterisk, okay, forward slash asterisk. This is the starting point of my comment, and asterisk forward slash is the end point of my comment. So I can write my comments okay as many lines as I want. Okay, so this is how I can use multiple line comments. Okay, so starting point is this and end point of the comment is this. This is known as multi-line comment. And the final kind of comment is this forward slash double asterisk. So you can see that this one was gray in this one was gray in color, but this one is blue in color. Okay, so don't think that both are same. This one is starting with forward slash single asterisk, but this one is starting with forward slash and double asterisk. So this is known as documentation comment. Okay, so this particular comment style is used for creating documentation about your Java program. Okay, it's used for creating documentation. So remember this, there are three kinds of comment: single line comment, multiple line comments, and the documentation comment. Okay, and you can end this with single asterisk and a forward slash. So this is it. We have completed this chapter. So I'll stop here. Thank you.